नमस्कार नमस्कार. अरे अरे अरे.
Namaskar. Good morning.
Good morning. Acha, now me and Dr. Ranjita also I requested her just to connect. Yesterday there was a meeting with the Professor Milos Manik. He was, I think he's not feeling well. That's why he's not
Okay.
able to speak. Yesterday there was a meeting with the Professor Milos Manik. That one chapter meeting. At that time, sir is not feeling well. That is the reason he is not able to join today. That maybe.
Okay.
Let us wait
Okay.
another 2 minutes. Another 2 minutes. What you are thinking?
Just wait. If he
Okay, so let the audience minimum 50. Virtual means 50, only 19. You, me, that is -5. Only 14 participants have joined. So physically they are present, na?
physical they are present.
Okay, my voice is audible to you all?
Yes, sir.
Okay, okay. I'm waiting. Whenever you will have a call, then I'll start.
Okay.
We extend our warm regards to all the dignitaries and our heartfelt greetings to the participants, media personnel, and students seated in this august gathering. Today, we embark on the opening chapter of this prestigious journey, setting a high benchmark for the technical discourse that will unfold. This conference serves not merely as a meeting of minds, but as a gateway to a future where intelligence meets infrastructure. It's my honor to invite Dr. Chinmay Kumar. He is a distinguished academician currently serving as the professor. He is currently serving as the professor and director of the School of Electrical Engineering at deemed to be university. With a career spanning over 32 years, he holds a PhD from Jadavpur University and has held pivotal leadership roles at BIT Mesrab and BIET Bhadram, a senior member of the IEEE and a fellow of the Institution of Engineers. His global footprints include collaborative research at the University of Zurich and several primary institutions in London, cementing his reputation as a visionary in power systems and smart grid technologies.
Prolific researcher and mentor, Dr. Pantroy has authored over 330 research articles and successfully supervised 29 PhD scholars today. His contributions to soft computing and renewable energy have earned him prestigious acclaim, including the Outstanding Scientist Award 2020 and the Of Affairs of Sports. Government of India currently serves as the chair of IEEE Industrial Electronics and Consumer Technology Society, chapter in Bhubaneswar. He continues to drive innovation and excellence in global technical education.
Over to you, Nasa.
Okay. Thank you. Thank you, organizing team, for making the nice introduction. My voice is audible?
You are not audible, sir.
Yes, I am audible. Okay. So, so very quickly, because today the keynote session was the keynote speaker was the Professor Milos Menik. So I am very much happy to be the first, the day zero, as you are saying. Today is 19th February 2026. It is the first international conference on artificial intelligence and machine learning in communication and power system, AIML CPS 2026. So it is organized by Department of Electrical and Department of Electronics and Telecommunication Engineering, Parala Maharaja Engineering College, Berhampur, Odisha. And the conference date is 20th, 21st. Today is the pre-tutorial sessions. And Professor Milos Manik is not feeling well. Yesterday there was a meeting. At that time also we observed that he was not supposed to, he has some physical problem or some medical problem with the. So today, Dr. Bhagat Panda, organizing secretary, requested me just to manage the session as today the first session. So as far as my competency and also my teaching experience for 34 years, so I will speak what is the spark grid. So before that, I can say Milos Manik is the very. I will try our best to make him connection during the inaugural session tomorrow. So today also I will make some connection. Professor Milos Manik is a globally recognized leader in artificial intelligence, machine learning, and cyber security with a particular emphasis on protecting critical infrastructure and industrial control system. He is the professor of computer science and director of Virginia Commonwealth University. So let us hope for the best. Tomorrow, if he is available during inaugural sessions, I will request sir just to connect for 10 to 15 minutes. Till now, he has not also uh, joined. So for last from 4 a.m. today morning, Dr. Bhagavata, are you listening to me? From 4 a.m. I am just connecting to Professor Milos. Now his mobile phone is switched off. That means he has some problem or he has been assigned some. So with this input, thanks to organizing team headed by Professor Bhagavat and his team, I know what is the difficulty level to organize such type of 2 days conference, including 1 day tutorial session with the different keynote speakers. I have seen around 10 keynote speakers are there. Professor, so my best friend, Professor Sanjeev Kumar Ponda, he is the Professor National University Singapore. Then Narayan Prasad Padi, he will also the keynote speaker. Then Dr. Vidyadhar Subudhi, then Dr. Nan Kishore, then Subransu Ranjan Samantara, my best friend, then Devi Prasad Priyabrata Acharya, he is from NIT Rourkela, Kailash Chandra Rai, IIT Patna, and Jugal Kishore Sahu from USA, and Sahabaj Sarik, senior silicon architect from the Bangalore, semiconductor Bangalore. So I have seen the keynote speaker, the list of the keynote speaker and the list of the uh, that acceptance for presentation. It is very excellent. With this input, I request my screen is visible or not. So let me share my screen. My screen is visible, yes or no?
Yes, sir. Yes, sir. Yes, yes.
Yes. So how much time you are giving to me? Now it is 9:20. Let us make another 30 minutes for presentation, another 15 minutes for discussion. Is it okay?
Yes, sir. It's okay, sir.
Okay. So coming to smart grid, just I'm just referring optimal placement of PMU. PMU means phasor measurement unit, and it is not a only electrical related. It is a common title. It is meant for your computer science and also your electronics and also electrical engineering. So smart grid means a traditional grid plus two-way communication. That is, we can say traditional grid plus communication is called a smart grid. So whenever we're saying smart grid, at that time, the smart meters, the components related to smart grid, people are talking about smart. When you see any IEEE transaction for last 2 decades, people are talking about smart grid in various aspects. So we can see this is one of the challenges, optimal placement of the PMU phasor measurement unit in smart grid. So the components used smart meters, sensors, and intelligent electronic devices, IED. Then communication network, control centers, that is SCADA, distributed energies resources, substation automation, demand response systems, and energy storage system. There are 8 very key components of the smart grid. I repeat. So whenever we are saying, coming to our outlines, this is the outlines, introduction, objective of this problem, smart grid, then PMU, what is PMU, then optimal pleasure with some technique I have used. I means my research scholar has used and just 4 years before, and I have modified some slides accordingly. I'll show make presentation. Then the results and conclusion. Coming to phasor measurement unit for smart grid, you understand these are the things we should understand. What is the main characteristics of the PMU? High resolution, wide area measurement system, PMU based dynamic state estimation. You see, all the components what I'm showing, it is a combination of a control, mainly control system, and also more application of the information technology or computer science engineering. So now AI ML integration, cyber security enhancement, like that. So edge computing, this is edge computing with the PMU with the renewable integration, cloud-based synchronous phasor analytics, time synchronization alternatives, PMU assisted wide area protection. I repeat. So these are the characteristics of the recent trends, recent trends of PMU, which is available or which is supposed to be connected in the smart grid. Then coming to PO, this as an engineer, we should know what is the, as an electrical engineer, we should know what is the POSOCO, Power System Operation Corporation Limited. So consists of 5 regional load dispatch center, and that is the National Load Dispatch Center with effect from 1st October 2010, and is responsible to monitor and ensure round the clock integration operation of Indian power system. So the grids are one is your North Regional NRLDC that includes Delhi, Haryana, like that up to Uttarakhand. Then WRLDC, Western Regional Load Dispatch Center, that is Maharashtra, Gujarat, Madhya Pradesh. As an electrical engineer, we should know what are the different types of load dispatch center, regional load, state load dispatch center, and national load dispatch center. Broadly, there are five. One is the northern, then the western, then eastern, then southern, then northeastern. So now, PMO installation initiative in India. This is the last of the power system. Indian power system has adopted this technology in the year 2010. So Unified Real-Time Dynamic State Measurement System (URTDSM) project includes more than 1,400 PMUs in the field and PDC at 32 state load dispatch center and 5 regional load dispatch center (RLDC) and NLDC. So these are already located. If you will say where it is located, then the answer is the smart grid allocation. Whenever we'll say smart grid location and deployment initiative in India, we can say smart grid, National Smart Grid Mission, NSGM, National Smart Grid Mission, Pan India Framework. India has an overarching program called National Smart Grid Mission, NSGM, under the Ministry of Power, which coordinates smart grid initiatives nationwide. It works through state level project management units, SLMPMUs, formed in multiple states, including Andhra Pradesh, Assam, Delhi, Haryana, Maharashtra, even in Odisha, Tamil Nadu, Telangana, West Bengal, and others. So these are the states coming under National Smart Grid Mission. I'm confused whether my voice is audible or I'll make slow. Dr. Bhagwat, can you suggest me? Is it okay, or
Yes, sir. Audible, sir.
is it okay, or I'll go very slow also? No issue. I have no issue. It is okay. I'm connected with the people, audience or participants sitting in the physical mode. Are they listening to me, or just I'm sitting and talking to a wall? Just give me some input.
Sir, you are audible, sir.
So I'll ask some questions also. So audience, before start my topic, I'll ask you some questions. You give me in chat box. You give me some names so that it will be more connected and also more participatory discussion. Whenever we are saying phasor measurement unit, at that time I am asking anyone who is sitting at the audience side, either in virtual or physical mode, at that time you should just tell me what is the meaning of phasor. Phasor, because we know phasor means rotating vector, and a phasor measurement unit, it is the angle between the two. One is current axis and also voltage axis. The power factor we know. Power factor means that is the ratio between cos phi. Kw is equal to kVA cos phi. Cos phi is equal to Kw by kVA. Kw means real power and kVA means apparent power. So the ratio of the real power and all these things, that is called as power factor. And we are talking about the phasor measurement unit. Just in the next slide, you can see these are the abbreviation you should know as an engineer of working with the smart grid. One is ADC, all know. Distributed Generation DG, EPRI, Electric Power Research Institute in America, then Geographic Information System, GIS, GPS, NLDC, Out Management System, OMS, Phasor Measure Data PDC, then as I told you RLDC. Anyone can say what is the full form of RLDC? Or Anchor, can you say what is the full form of RLDC? You are not listening to me. RLDC. Anyone? Hello.
Yes, sir.
Can you tell me what is the just seeing the just you see the my slide just to interact with me? Are you finding anywhere it is written SG? You're not finding.
Yes, sir. Yes, sir. SG Smart Grid.
Very good. Are you finding WAMS?
Yes, sir.
What is
Wide
the full
area,
form of that?
wide area measurement systems.
Which word you do not know? Wide area measurement system. Is it a new word to you? Wide area measurement system. You have in your curriculum you are reading your computer networking, wide area network. Are you have you seen somewhere it is written ESS?
Yes, sir.
What is the full form?
Energy storage system.
You see this slide and tell me, don't say from your memory. SCADA, what is the full form?
So,
You
what
are
is
not
SCADA?
finding. Yes.
Sir, supervisory control and data acquisition.
Do you know this super SCADA system? It is a very much useful tool in our electrical power system, not now, for last 5 decades. You know that?
Yes, sir.
Yes, sir.
Very good. Very good. I mean, you will say yes now, it is giving me energy to say good things to you. If you will sit idly, then I have no use. Simply I'll talk to a wall. So these are the abbreviation we should know as this, and very important word keyword is here, DSN. Are you finding DSN?
Yes,
Yes, sir.
sir. Demand side management.
Huh?
Demand side management.
Can you tell me what is the meaning of demand? What is coming in your mind? Better you say, so that I'll demand means it is a load, load side management or demand side management. Suppose we are the customer, we are getting power from the grid, and that how will manage the load as per you will get the more reliable and more power quality, because your Bhagavat sir is a giant in power quality. He's a man. He's a very good person in terms. I mean, very good fundamental clear in on power quality. If you have any doubt, you talk to your Bhagavat Pandit sir. So this is the last question to you. What is the meaning of smart grid? Anyone? I have already told you. Conventional grid plus communication is called a smart grid. Can you repeat?
Conventional grid and communication grid.
The communication means you see in it, these columns, it is written everywhere how the communication will be made through customer and also grid, and so that if you are in Delhi also, you can understand what is happening in your grid through your mobile phone. Coming to next slide. So this is today's talk is to minimize the number of PMUs, because PMU is very costly. Have you any idea what is the cost of PMU? Anyone? Just tell me what is the idea. Just like if I'll say the 1 kg of potato, its cost is to 20 rupees now. Similarly, PMU cost is how much? Just a common sense. Anyone? If you will say potato cost is 200 rupees, people will not accept you because 20 rupees maybe 25 or 15 it can be managed. If you will say potato cost is 200, people will laugh at you because the engineer means always
Good
you
morning,
should have
sir.
a very good observation. What is the range of PMU cost?
Sir, actually, you have only read the theory part. Actually, we have no idea what are the practical costs of PMU.
Judge, no, don't say no idea. Just you tell me common sense. What is the PMU? Anyone?
About equal
7 lakhs.
Echo is coming. I'm saying the answer. PMU cost is 1.6 lakhs to 16 lakhs. Now it is coming in, and now it is also decreasing its cost because of different types of IC we are using, which is very much viable and very much sustainable. So it range is 1.6 lakhs to 16 lakhs. Is it clear to you?
Yes, sir.
One word is written IEEE. Can you tell me what is the full form of IEEE? I'll ask you question, otherwise I'll not say anything. What is the full form of IEEE?
Sir, it stands for Institute of Electrical and Electronics Engineering.
Engineering me, engineers. Okay. BGWO, it is written, one technique. What is its full form? Binary gray wolf optimization technique. It is one type of soft copying technique. They're coming to next slide. Chalo. What is the motivation? Have you any idea of SDG? How many SDG we have? Sustainable development goals. Arey beta, yes, don't think that I am a computer engineer, I am electronics engineer, I am electrical engineer. I have no idea on SDG. SDG means whatever engineering, whatever technology. You know what is the mission of IEEE? Advancing technology for humanity. So your SDG, Sustainable Development Goals, 17 sustainable goals are there, and whatever motivation it is written, decarbonization, decentralization, and inability to expand energy system mean ever increasing strength on equipment and therefore much greater. With the evaluation of grid and addition of distributed generation, grid scale renewable energy storage, Indian power system network has very much complex. Similarly, with the fast growth of have you any idea on the distributed energy resources? That means renewable energy integration with the conventional. Distribute, like it may be solar, it may be wind, it may be biofuel, it may be your nuclear, anything. Wide area monitoring system for distribution system has a great scope. Coming to next slide. This is the smart grid definition. Anyone can read NIST. NIST Berhampur, it is not NIST Berhampur. It is National Institute of Standard and Technology, USA. According to NIST, this is the definition: a modernized grid that enables bidirectional flows of energy and uses two-way communication and control capability that will lead to an array of new functionality and application. This is as per the NIST USA. According to IEEE standard, the smart grid means it is a large system of systems where each functional domain consists of three layers: power and energy layer, the communication layer, and the IT or computer layer. As per definition of IEEE, PMU is defined as a device that produces synchronized phasor. देखो कितना अच्छा अच्छा चीज है, synchronized phasor, frequency and rate of change of frequency. Have you any idea rate of change of frequency? You know frequency, F is equal to Pn by 120. Phasor, you understand, that is a rotating vector. That means what is the angle between I and V, that will control phasor measurement unit. Phasor means the angle I and V versus and a rate of change of frequency. Anyone can say what is the meaning of rate of change of frequency? अरे ये सब नहीं हाँ tell me बेटा.
The rate of change of frequency is the speed at which the power system frequency changes with respect to the time.
Tell me again, you are approaching, but the keyword you are missing. Rate of change of frequency estimates from voltage and current signal and time synchronizing signal. This is very important. That means we have to making stamping between the current and voltage signals. That is called as rate of change of frequency. You are very correct, beta. You are very correct. Can you read the last line? What is the PMU? It is written as per the GPS.
So PMUs provide real-time synchronized measurements in power
Real
system.
time, you understand? Now the time is 9:45. At this time, how the grid is behaving, what is the customer demand, and what is the different types of power available, and what is the constraints of the grid. All the things are coming to in one place. That is called as real-time synchronized measurement in power system with better than 1 microsecond. देखो कितना टाइम जो rate of change frequency जो है ना, that 1 microsecond synchronization accuracy which is obtained by GPS signal. Now it is clear now about PMU. Yes or no? Tell me.
Yes, sir.
There are IEEE definition PMU and another definition. What is the reality? What is available in our real system? Coming to next slide. देखो कितना अच्छा स्मार्ट है. What's your good name, बेटा?
Sir, Soumya Sanjana Behra.
Soumya.
Yes, sir.
Soumya, my screen is visible, yes or no?
Yes, sir, it's visible.
Can you tell me, Soumya? Don't take it because you are representing all on behalf of all audiences. So Pandasar is there, yes or no?
Yes, sir, he is present.
So now you tell me, in a circuit, current comes first or voltage comes first? What is coming in your mind, you say? It may be wrong because I am a teacher, you are my student. In a circuit, current comes first or voltage comes first?
So voltage comes first.
It is wrong, beta. Current comes first. When current comes first, the drop across the element, that is called as voltage. So always you say I is proportional to V. Reverse is not true. V is not proportional to I. I is proportional to V. Current comes first. Is it clear, beta? What you are saying, that is called as EMF source, energy. Energy is there, and by that current is flowing through element I, V is equal to IR or V is equal to IZ, that is there. Now in same way, now you see this diagram. There are different components. You see left to right. One is generation. Then you see there is wind farm, energy sector, transmission. Soumya, I'm telling one line. Try to understand. Now engineering is not only electrical or electronics engineering. It is simply engineering. Why I'm saying I have just met one person from America who is working in a medical institute. It is a very renowned institute in America. 20% are doctor and 80% are computer engineers and electrical and electronics engineers. It is, if you do not know, it is the fact. So don't think that you will deal with only power and energy. You have to deal and even in health sector also, because maximum medical devices which is used in the recent trends in the hospital all are sensor based, IoT based, AI based, ML based, everything. So and more uses of in military or air force, that is deep learning. So those things try to learn by within this. So here you see it starts from generation, then wind farm, then industry, consumer and residential, and these are the rooftop solar. Now you see the power flow, solid line is your power flow in smart grid, and another blue line is there, power flow in the conventional power system. Now you see how smart we are doing. Are you listening, Soumya? Yes or no?
Yes, sir.
Bidirectional you see industry distribution network, consumer commercial user like your kid university or any residential distribution two-way, residential two-way, rooftop solar one way, wind farm one way. These are the distributed generation, wind farm, rooftop solar. And here you come in between that a big circle, you see distribution, transmission, data. You know power system comprises of five things. One is generation, then transmission, then distribution, then can you tell me another three, two? Anyone, Soumya? Generation, say generation.
So
Arey, you are
generation.
not saying. Generation, transmission, distribution, then
So
protection,
distribution of
protection, then
control.
eh, Arey, don't feel shy. I'll be more happy you will say wrong things. Correction is utilization. Because you see, we all are the customer who are utilizing. You cannot, whenever we are utilizing, we are giving also cost. What is the amount of we are using? That is the cost we are giving. So that is called as BOT. You know the meaning of BOT? What is the meaning of BOT? Board of Trade Union, that is kilowatt hour. Dekho, it is written. Utilities, I told you, utilities are poised to move from the traditional power system to highly flexible, secure, like that. Chala. This is the difference between conventional grid and smart grid. Soumya, are you listening to me?
Yes, sir.
There are
Listening.
how many points it is written? One is digitized, another is bidirectional, distributed generation, dispersed generation, many sensors, highly monitored, automated control, vulnerable to security issues, because cyber security is very, very important for a smart grid. Then fast response. You tell me which word you do not know. Chalo. Yeah. Coming to challenges in smart grid. Reliable and fast communication, big data, cyber security, WAMs, then suitable converter technology, multi-level, 9-level inverters are also coming, RES integration, optimal seating, regulator, these are the things you should know. Then issues of EMS and SCADA, that already I told you, existing systems and power system energy SCADA, that PMU is superior to SCADA. Previously SCADA is used, now PMU is superior to SCADA with respect to speed, performance and reliability. I request all the participants who are sitting, virtual and physical, please read this line in a loud voice. So may you read?
Yes, sir.
PMU.
Existing.
That blue line.
PMU is superior to SCADA with respect to speed, performance, and reliability.
What is the meaning of speed? You understand. What is the meaning of performance? You know, better efficiency. And what is the meaning of reliability? You know. Yes or no?
Yes. Yes,
Now
sir.
you tell me, PMU is better or SCADA is better?
So I guess PMU is better.
You tell everybody who are present there. Tell. Then coming to PMU technology, already I told you, synchro phaser, all these things. Synchro means always constant frequency and constant speed. This is the block diagram of PMU. This is very, very important, block diagram. In the block diagram, you see analog input is there. So then GPS receiver, phase, all the things, PLO, phase locked oscillator, then 16-bit AD converter, phaser, microprocessor. So it is written very clearly. These slides I will share with the Panda sir. He will share to your all the participants, no issue. So here the very important is the sampling rate chosen for the sampling process dictates the frequency response that all the analog signals have the same phase shift and attenuation, thus assuring that the phase angle differences and relative magnitudes of the different signals are unchanged. This is the integration of PMU data. You see PMU, there are three PMU there, then PDC. That is already I told you V, current, voltage and frequency measurement substation by the PMU. Then data input and management control the center PDC. Then monitoring, visualization, application, phasor data, then system control remedial action. It will going to directly the engineers. Then synchrophasor technology has brought about a paradigm shift from state estimation. This is the control engineering. Those who have not read try to understand what is the meaning of state estimation and state measurement and space. When a phasor measurement is time stamped against GPS universal domain, it is called a synchrophasor. Samya, are you there? A synchrophasor system is wide deployment of PMU and dedicated high-speed communication to collect and deliver synchronized high-speed. Then this is the need of synchrophasor to obtain high-resolution data. The data from different locations are not captured at precisely the same time. Voltage, active power, and the reactive power normally do not change. Samya, can you tell me what is the meaning of reactive power? Samya is not there. Okay. System monitoring is crucial during disturbance and transient to capture dynamics. So these are the application of PMU, post-disturbance analysis, stability monitoring, thermal overload monitoring, power system restoration. Now the very important terminology is coming. Anyone can say, Samya, are you there?
Yes,
No.
sir, I'm present.
Very important terminology in any transaction paper you see, it is coming. Can you tell me that word in power system?
So can you repeat the question again?
I am saying the very one keyword is coming in any transaction paper, journal paper regarding power system smart grid. What is that word? And you say AI, IIT, NIT, all the people are working, research scholars are working on that word. What is that word?
So I guess it's advanced
Nah?
metering infrastructure.
You are
Advanced
belong
metering.
to which semester, Soumya?
It's a fourth semester.
Oh, then there you have some small idea. I'm saying the answer is resilience. Now, resilience is a common phenomenon and common keyword by which we can make stable our smart grid. Resilience. That means whatever things happen, how it will be recovered within no time. That is called a resilience. Is it clear to you?
Yes, sir, it's clear.
Now the smart grid communication, you see, whatever these are the standard. IEEE C 37.1. What is its meaning? It is written here. IEEE 1379. What is its meaning? It is written because you see, Somya, you are fourth semester. These things from today try to learn what is the meaning of standardization. IEEE is a standard. So whatever components, what are the meters, what are the devices we are using, you talk to your Professor Ponda sir. He is the right person to make you what is the meaning of standard. Standard without standard, electrical engineering cannot use any. Even if where also we are maintaining standard as per the IEEE. IEEE 1547, IES 60870, IES 61850. These are the standards that you read. Now coming to our optimization problem, we are now, this is the your what is that? This is the objective function of minimize effects subject to GIX less than equal to and that you come. This is the optimization technique, different types of obtain one is linear programming, integer programming, quadratic programming, non programming, stochastic programming, dynamic programming, combinatorial programming, infinite demand, constant like that. And advanced optimization technique is hill climbing. And what is the? It is a graph search algorithm where the current path is extended with the successor node. This is the topic in the optimization technique we have already used. GWO, Gray Wolf optimization. What is the concept? You know, listen. I request all the participants, please read this slide so that you can understand everything. The wolf has a great capability. This is the very peculiar characteristics of a wolf. What is that? The wolf has a greater capability for prey capture at the top predator in the food chain. This is number one. So it is the technique introduced by Mirajali in 2014. 2014. It is as a revolutionary heuristic swarm of intelligence. Wolves like a socializing and they also have a rigorous social structure. GW algorithm simulates the natural leadership structure. Then these are the different types of constraints. The prey is being tracked, condition, pursue the prey, immersion the prey, like that, like that. Then you see golf. How many wolves are present here?
So 5.
That is the problem. It is written, you see, 5 to 12.
From 5 to 12.
Ah. No issue, beta. I देखो कितना अच्छा अच्छा ये I will not say anything because you cannot you just understand the concept of the smart gate. These are the wolf how this is pyramidically they are doing delta, alpha, beta, delta, omega. These are the different types of. Finally, our objective is alpha. This is important. Hunting mechanism. देखो कितना wolf है. It consists of three processes: searching, search करो, encircling and attack. जैसे मिलिट्री में होता है search, encircling, attack. These are the mathematics. No need to explain. Surrounding prey. These are the problem formulation. These are the observabilities, mu, redundancy, effects. These are the things. This is the flow chart. If you want that, somewhere are you able to listen, see the flow chart? Yes or no?
Yes, sir.
Whatever terminology is coming now, it is coming under the mathematical model. I have not done anything. It is available in the internet. I have changed some constants and I have taken some other things. After that, my research scholar has simulated and getting the good result. This is the thing. Optimally allocated PMU in IEEE 14 bus system. You see optimal here 14 bus 4 MOU there, 30 bus 10, 57, 17. Now previously we are using 52. Now we are making this technique. It is coming 10. Are you getting my point? So it is less. If you will use minimum number of PMU, then cost will be less. So like that it is there. These are the comparisons results of PMU allocation. These are the graph. Then conclusion, binary gulp PGW. Then IEEE 118 bus system is also PMU, future scope. This you read. This is the very important embedded system technology. The distributed system is becoming more common with inclusion of distributed. This is the very challenging. Now this is the reference. Now the question is this. Read the question and read the answer. Soumya, is power a phasor? What is the answer? It is written usually.
So although the complex power S can be expressed as a polar number, it is not a phasor. Remember, phasors come from sinusoids in the time domain.
Then you tell me, is power a phasor? Power means your S is equal to V into I. Is it a phasor? The answer is no. Then second question, what is that? Last question.
Is impedance a phasor?
Now, what is the answer?
Although the impedance is the ratio of two phasors, it is not a phasor because it does not correspond to a sinusoidally varying quantity.
Is it clear, beta, Soumya? So impedance is not a phasor. Then coming to why do phasors rotate in anti-clockwise? What is the answer?
So because that's how mathematicians conventionally portray angles increasing in an anti-clockwise direction.
I
The reason is
request all the members who are present here, please write this question and also answer what is written, because this is the outcome of this talk. I'm giving you 2 minutes. What is written? How many data points are obtained in the output of PMU per second? So answer is written. Somya, you say who are present physically to write on the copy, and after my talk, I'll see randomly and I'll ask someone to see those copies. Are you getting my point?
yes, sir, we're sharing and everyone will like it.
Huh? So you read answer. How many? You read the question and read the answer.
So how many data points are obtained at the output of the PMU per second? The answer is compared with SCADA systems, PMUs provide sample data at a much higher rate, normally at 30, 60, or 120 samples per second, as opposed to traditional SCADA refresh rate of seconds or even minutes. As a result, the amount of data generated by PMUs is significantly larger than that of a SCADA-based system.
Whether the participant has written or not, tell me first.
Yes, sir, they are writing.
When they will complete, then you read the second question. Chalo, second question पढ़ो.
So how PMU improve the operational efficiency of smart grid? The answer is the optimal PMU placement decreases number of PMUs, that reduces cost of system. Using PMU in smart grid increases reliability of power system stability. Therefore,
Your voice is not audible. Am I audible?
yes, sir, sorry, sir, we lost our network.
Oh, you from your side it is there. Okay, no issue.
Yes,
I
yes.
thought that
Sorry.
from my side. No issue, no issue. Now it is visible.
Yes, sir, it's visible.
Okay, beta. Second question: how PMU improve the operational efficiency of smart grid? Read and say. Anyone can help. Somya is reading always. Another boys, please come forward. No one. Okay.
Yes, sir, coming.
Read. Samya, another your friend is there. He should read also.
Yes, sir, he has come.
Good morning, sir.
Beta पढ़ो. How
The
PMU improve the operational efficiency of smart grid? You see, last 50 minutes we are discussing. I'm saying what is the important points in terms of question and answer. This is the impact of this talk. Read that answer.
yes, sir. The optimal PMU placement decreases number of PMUs, that reduce cost of system, and using PMU in smart grid increases reliability of power system stability. Therefore, it is possible to monitor the power system observability by using PMU.
Whether the audience are writing or not, they tell me.
Yes, sir.
They have completed or not. You check the copy. You check the copy whether they have completed or not. Because they are sitting just idly, just like a film hall, it has no meaning.
Okay, sir. Give us 1 to 2 minutes.
They should write, no issue. I'm waiting.
Yes, sir.
After that, I will make an examination and I will give the best audience who will say me the right answer. Tomorrow I am going to your institute. I will give some surprise prize to him or her. I will ask one question. Who will give me answer? I will give a surprise prize there. Prize is that is not too costly, but I will give something. Chalo, third question.
Okay, sir. We can go for our third question.
Read.
Okay, sir. Why do feature rotate anti-clockwise? Because that's how mathematicians conventionally portray angles increasing in an anti-clockwise direction. The reason is straightforward. You start with a number line which conventionally is horizontal, has 0 or smaller numbers on the left and larger number on the right.
Are you able to understand these lines?
Yes, sir.
These are the question people are asking during your placement. Chalo, already Soumya has what is your good name, beta?
Sir, Rasmiranjan Mahapatra.
Rasmi. Soumya already read these 2 points is for a phasor and is impedance. Coming to next slide. Chalo. I request Rasmi, you read first question.
Okay, the question is, what is WAMS in smart grid? WAMS stand for Wide Area Measurement System. In smart grid can be defined as a system that captures measurement in the smart power grid over a wide area across traditional control boundaries, and then uses those measurements to improve grid stability and events through wide area situational awareness and advanced analysis.
Okay. Then like that, these questions are there. What is the synchro phasor data and what is the phasor data concentrator? These all are related to your PMU. And the last question you read, where are PMU placed? It is very important. Soumya, you read.
So PMUs are situated in power system substations and provide measurement of timestamp positive sequence voltages and currents.
So I request, request Soumya, tell me honestly whether the people are writing or not. That is very important.
Yes, they're writing. We have
No, don't
shared.
tell me lie. Don't tell me lie. They are not writing. They are writing
Yes, sir.
yes or no.
Yes, sir, they're writing, sir.
So you tell me when they will complete, then I will say.
Okay,
You
sir.
tell them they should write quickly. It
Okay,
is the
sir.
last
Okay, sir.
slide.
Yes, sir.
Now I'll ask after writing. I'll ask a question. Only one question. Anyone can give answer. I'll give a very simple appreciation. Tomorrow I'll be meeting to him or her, and I'll give small, one chocolate tomorrow, not today. So and when I will say whenever you will complete the writing.
Yes, sir, they have written.
You tell me one participant who has a paper or who is the from third year. Who is the participant? Any participant you tell me name so that I'll ask you. Choice is yours. I'll ask him or her. I'll ask one question.
Sir, Jyotirmay Didi.
Jyotirmay, you call her to your mic.
Yes, sir, she is here.
Yes, sir. Good morning, sir.
Jyotirmay,
Yes, sir.
can you tell me, because your friend asked, I tell me honestly whether you have completed all the question and answer.
Yes, sir. I have written, sir.
All the questions answers you have written in complete form, yes or no?
Yes, sir. Yes, sir. I have written.
Very good, beta. Very good. So you will get a special appreciation from me tomorrow. And another last question to so coming to sorry. Just 1 second, 1 second.
So your screen is not visible. Slides.
You people are very energetic. Let me. Now it is visible.
Yes, sir, it's visible.
Okay. Then last slide. Jyotirmay, you tell me what is written. Jyotirmay,
Sir, thank you.
what is written?
Sir, thank you all.
So you will get one chocolate from me because you have given me answer very nicely.
Okay, sir. Okay, sir. Thank you, sir.
Tomorrow I will give you a chocolate, no issue. Only thing is in a surprise question coming now. Bhagat Panda sir is there.
Yes, sir, he is present.
So I am asking randomly. Only one student I will ask. If he or she will give, then I will understand that you the people are listening to me. Subhranshu Sekhar, are you listening to me? Subhranshu Sekhar, are you a participant or student? Okay, that is the problem. That's why I'm interested to interact my student. Acha, Srushti Sikha Tripathi, are you there?
Yes, sir, she is present.
You call her.
Yes, sir, I am there.
Srushti Sikha, can you tell me within two numbers, 4 and 3, which is greater?
Sir, 4 is better.
Srushti Sikha, listen the question perfectly. There are two numbers, 4 and 3. Which is greater?
Sir, 4 is better.
You tell me complete sentence. 4 is greater than 3. ऐसे बोलो.
Sorry, sir. Sir, 4 is greater than 3.
Correct. -4, -3. Which is greater?
Sir, -3 is greater than -4.
Oh, correct. So now the surprise question is coming. 4 J. J means root over -1 in electrical engineering. 4J. Another is 3J. Which is greater? Because we have read phasor measurement unit. J. J is very important. So 4J and 3J. Which is greater?
Sir, 4J is greater than 3J.
Okay. So, Samya, one chocolate I will provide to Srushti, but she will take only half because she has not given me right answer. 4J and 3J, as it is a complex number, already I have given you hints. It is impossible to say which is greater because J is neither positive nor negative. This is the answer. Arey, Anchor, Rasmi, not present. Samya,
Yes, sir. Yes, sir.
Yes, sir.
so
Yes, sir, I'm present.
Srushti will give half chocolate and another half you distribute yourself. Okay, tomorrow I'll give.
Okay, sir.
So thank you all for
Thank you.
patient hearing. Thank you all. Bye. Over to Bhagat Panda sir.
Thank you, sir. Hello. Thank you, sir.
Yes, yes.
Explained here. You
Any question from audience side? That is important.
For our IEEE from side also IEEE conference. So thank you very much. Thank you very much, sir, for delivering the nice talk. Thank you. So again, we'll meet tomorrow.
Okay, so can I leave now?
Yes, yes, sir. Just how you can take the photo, sir.
Okay. So I request any question from your side, you take my mail ID. Any question. It may be small question also, research question, please send to me. If I am not able to speak, I can search and I can give the answer also. Thank you all.
Okay, thank you, sir. Thank you.
So I'm leaving.